All right, so in the last video, we talked about this idea of causal inference, and really what it boiled down to, well, this idea of like trying to get at the causal effect of some treatment. In that case, we were talking about an infrastructure program, right? The causal effect of that infrastructure program. What we needed to do, if you remember back from last video, what we needed to do was figure out a way to get rid of this selection bias, right? Because if we can get rid of the selection bias, right, if we've got an apples to apples comparison, right, in other words, if we've got a situation where both, in that case, both cities would have looked the same if there had never been any treatment for either of them, right? Then we can look at then we can observe the difference between what happens to a treated city and a non-treated city, and that's going to be our treatment effect, right? And if we're doing over a bunch of cities, that's going to be our average treatment effect when we take the averages, right? So it came down to trying to figure out how to get to these apples to apples comparisons, or how to get rid of this selection bias, right? So we're going to talk about in this video and the next couple of videos, we're going to talk about different empirical strategies, right? You'll hear economists using that a bunch. An example would be a difference in difference strategy. That's an empirical strategy, or even a regression where you've got you're including some control variables. That would be an empirical strategy. And really what we mean when we say empirical strategy, kind of, there's a lot to it, but really what it boils down to in terms of the intuition is that we're making some assumption about how treatment was assigned, right? Why did some cities get treated and other cities not get treated, right? In order to get to a measurement of that treatment effect, that average treatment effect, right? Remember up here, in order to get to this average treatment effect from the stuff that we can actually observe, right? We need to make a few assumptions, right? And if those assumptions are accurate, then our estimate of the average treatment effect is going to be accurate. If those assumptions are not accurate, then we're going to have some selection bias in our estimate of what we think the average treatment effect is, right? So we're going to be making some assumptions about how treatment is assigned. Now, the easiest situation, right, the sort of gold standard situation is when we've got a randomized controlled trial, right? So this is like, if you think about a pharmaceutical trial, they're trying a new drug, right? They're going to take a bunch of patients that sign up for the trial, and they're going to flip a coin and say, you go in the treatment group, you go in the control group, right? You're getting the pill, you're not getting the pill, right? And so what happens when you've got this randomized control trial, and the key part of that is that you're assigning people to treatment randomly. So we got random assignment to treatment, right? That means, if you think about what that means in terms of our notation with the potential frameworks, the potential outcome framework, right? That means that the group that gets treated, right? Remember, DI equals 1. So that's the group that gets treated. So if we're back in our infrastructure program example, DI equals 1 would be city I. So this term would mean the average of the potential outcome if these cities were not treated for the cities that did actually get treated. So this is the counterfactual, right? What would have happened to those cities that did get treated had they not gotten treated, right? If those cities were assigned this treatment randomly, then we can say that on average, right, they would have looked the same as the cities that didn't get treated, right? In other words, in our notation here, right, we're going to have this equality, right? So this is the cities that didn't get treated what their potential outcome from not getting treated would be, right? And so this is observed, right? So we observe this, right? We don't observe this. This is the other door that we don't see behind because it was never opened, right? Because you can't observe both potential outcomes at the same time. You can't observe a city if it is treated and if it's not treated at the same time. But here, because these two things are going to look the same, right? We're able to sort of guess what would be behind that door, what would be behind that potential outcome door that we didn't get to open, right, for this group that was treated, right? And we're able to guess at it because we know what happened to the other group. And the only reason there's, you know, one city in one group and the other city in another group is because of a coin flip. So on average, those two things are going to look the same, right? So here, our assumption is just this. We've got random assignment to treatment. And if we've actually randomly assigned to treatment and we've got a big enough sample, this should work, right? And so let's think about what this means if we've got this, assumption, what this means for our equation up here, right? What is our average observed difference going to look like in terms of the average treatment effect and the selection bias? So let's take this, and then we're going to put in this assumption that we've got, which is this guy equals this guy. So if those two things are equal, what can we do here, right? Well, we know basically what we can do. Here, I'll do it in 2 lines so we can sort of see what we did, right? We can substitute in this guy for this other guy here. Okay, so we know this is true now, right? So I've just substituted in here. So what that means is this thing, right, which was our selection bias, right? In other words, that's going to 0, right? And what does that mean for us? That means the average observed difference is going to equal the average treatment effect. Right? So if we're in this great situation where we've randomly assigned treatment, it's then very easy to figure out what the average treatment effect is. All we need to do is, you know, take the average of the treatment group, compare it to the average of the control group, right? Okay, so this is a case where we're getting rid of the selection bias, right? Another way of thinking about it, sort of in simple terms, is we've got an apples to apples comparison. Right? No one's choosing to get the treatment. There's not something else that's different between the treatment group and the control group, right? They're both going to look the same because we've just flipped a coin to decide who's in which group, right? And so when that's the case, we've got our apples to apples comparison. The counterfactual of our treatment group is going to look like our control group, right? That's another way to put it, right? What's behind that potential outcomes door, right? If we remember back to our sort of example up here, right? For our treatment group, right? That was the group where we got to see behind the potential outcome with the treatment. We don't get to see behind the potential outcome without the treatment. We can know what's behind that door though, because we see the control group, and the only reason people are in that control group is because we flipped this coin, right? There's not some choice to get into that group or some characteristic that led to people being put in that group, right? So we've got a really good estimate of our counterfactual here from our control group, and that allows us to kill that selection bias and just look at the observed difference and find that average treatment effect. Okay, so let's say we ran a randomized control trial, and we want to analyze this, and we want to tie it together with how we've thought about regression, right? So you guys have you guys have spent some time in econometrics, learning about regressions, so you'd be familiar with something that looks like this, right? So here we have our outcome variable, our observed outcome, right? We've got our intercept here. We've got our treatment variable, right? Here it's, you know, an indicator, a 1 if you're treated, a 0 if you're not treated. This is a coefficient. That's a coefficient of interest, really. It's you know, in this case, it's going to be, and we'll see in a sec, it's going to be the average causal effect of the treatment, right? If we've got this random assignment to treatment, and then we've got our residual here, right? Our error term. Okay, so dependent variable, we got our treatment variable, intercept, residual, and our average causal effect of treatment, or average treatment effect is what we've been calling it. Same difference. All right, so let's put these two things together, right? How does running this regression relate to this sort of causal, the causal inference framework, this potential outcomes framework that we've had above? Okay, so let's think about that. So let's look at what happens for these different pieces. So up top, right, we had something that looked like this, right? Now remember that's going to be the same as this guy because this is just our observed outcome, the average of the observed outcomes for the treated group, right? Here, this is the average of the potential outcome if treated for the treated group. So those two things are going to be the same, right? So we've got that up top. What's that going to look like if we do that for this regression, right? So what is the average given the di equals 1? Well, all we're doing is we're taking the average of the other side if di equals 1, right? So we've got the average of a constant is going to be a constant. This di equals 1, so we're going to get a beta for everywhere, right? Because then we just have this constant beta. And then we've got the average of our error term, right? The average of whatever's left, in other words, if di equals 1, so for the treated group, right? Same idea for di equals 0, right? It's going to look similar, but no beta here, right? Because we're setting di equal to 0. Okay. So let's put this together. Let's find what this average observed difference up top is in terms of our regression here, right? So in other words, what is this guy? It's just going to be the difference between these two here, right? These alphas are going to drop out, so we're going to end up with a beta plus these average residuals for each of these, the difference between these average residuals for each of these groups. Now, the interesting part here, so this is another way of saying, here's our average observed difference, right? And then, so it's kind of annoying. And then here's our average treatment effect, beta. And then this last piece is going to be our selection bias, right? So if we've got a situation where we've randomly assigned cities to the treatment and control group, we've got that random assignment, then this piece here is going to drop out, right? Because the residuals aren't going to look any different for one group versus the other group. because they've been randomly assigned, right? Another way of saying this, and the way you may have said it in econometrics, is that if there's no correlation between whether you're in the treatment group and what's in your error term, what's in that residual, right? There's no correlation. That means we're not going to have any selection bias, right? If there's no correlation, then this thing is going to be equal to 0, right? And we've got no selection bias. This was, if you remember, this is one of your big Gauss-Markov assumptions, right? That you went through in econometrics, right? So this is all just to give you a sense of how these two pieces tie together, right? They're both kind of getting at the same idea from different directions. And I think the causal inference potential outcomes framework is going to be useful for really thinking through the intuition of what you're doing when you're running these regressions and what assumptions you're making, right? Because if you're or you're sort of analyzing someone else who's done this, right? If you're not understanding the underlying assumption, right, behind the empirical strategy, you're not going to understand the quality of the evidence, right? You're not going to be able to assess whether they're telling you like a true causal effect, or whether, you know, there's a bit of selection bias in there. There's a bit of, you know, it's a little bit more on the spectrum towards correlation than causation.